So we are jumping into section 4.2 right now. And in section 4.2, we're going to learn about the difference between observational studies and experiments. And out of all of the stuff that I will teach you this year in AP Stats, this is one of the most important topics. Being able to distinguish between those two things and being able to talk about what each of these things is good for. Long after you guys have graduated and you've taken this class and I'm just a distant memory for you guys. I really hope that this topic right here sticks because being able to tell when something is an experiment and when something is an observational study makes a big difference in what kind of conclusions you can make about a problem. So when you guys are reading articles or you hear something about a study in your adult lives, hopefully you'll be able to think back to this and it'll kind of guide the way you analyze a study. So go ahead and read this problem to yourself. Pause me for just a second if you need to. And I'll summarize just the key points right here and we'll start talking about what's going on. So the idea in this problem is that we are in Cincinnati collecting data from a children's hospital there and looking at 4,700 children between the ages of 4 and 15 and their parents, and then looking at ADHD rates and whether or not the mothers smoked when they were pregnant with that child. So obviously, if they're looking at the kids and they're 4 to 15 years old, they were probably asking the mother in like a survey or something, did you smoke while you were pregnant with this kid? And they found that 4% of the kids overall had ADHD, but they realized that of the children whose mothers smoked, so the people who smoked, their kids were over twice as likely to develop ADHD as someone who didn't smoke. So that is the finding of the study. So let's talk about a few things with regards to this problem here. Ignore my blue for right now, and let's look at this top question. Based on this study, should we conclude that smoking during pregnancy causes an increase in the likelihood that a child develops ADHD? If we were doing this in class right now, we would have a discussion about this question. I would ask you guys what you thought. You would talk about it at your tables. You would talk about it with me. But this isn't something where I just want you to listen to my answer and know what's going on. So I need you to pause this and actually think about this for a minute. Can we determine, based on the results in this study, that the smoking caused the increase in the ADHD? Okay, so pause me and don't keep playing until you have an idea of where you want to go with this. So the actual answer that I hope you guys were able to wrestle with here, kids will mistakenly go, well, it was twice as likely that the smokers' kids had ADHD, so that seems like a pretty big deal. And that's where a lot of people who are more inexperienced with statistics would tend to go. If you think about it, though, based on the structure of this study, there's no way to say for sure that the higher ADHD rates were because of the smoking. Okay? Think about mothers who smoke in general. It's pretty well established that you should not smoke during pregnancy. It's not good for the infant, and any doctor you go to will tell you that. So if a mother is already smoking during pregnancy, they could be doing a lot of other things too that are not good for the developing child. So perhaps, for example, a mother who is not smoking is also not exercising. And that it's the lack of exercise that is actually causing that increased rate in ADHD. Maybe mothers who smoke are more likely to also drink, and it's that's causing that increase in ADHD. We have no way of knowing for sure if the smoking is the thing that causes the increase in ADHD. There's a lot of other factors that could influence it that could be tied to that idea of smoking. If you smoke during pregnancy, you're also more likely to do X, and it's X that causes that increase in ADHD rates. This concept that I'm talking about right here is the concept of confounding, which is a vocab word, and you've got a little definition right here. But I use this visual a lot in class, so you'll probably see me do this in person too. But picture I've got this smoking, and I've got I'm going to go with lack of exercise, not exercising during pregnancy or making other poor health choices, not eating well, whatever it may be. Those factors are tied together, and we really don't have the ability to separate them. So we got smoking, we got not enough exercise right here. Those are tied together. And yes, there's a higher rate of ADHD, but we don't know which of these things it was. In order to know for sure what was going on, we would have to find a way to separate those two factors. Okay, and we'll talk about that as we go later into this slide. Now, my exercise example is one of many. You guys might have thought of many things that I didn't mention right here, but that's what confounding is. We don't know if it's what I said or what you thought of or what somebody else thought of. We can't say which one of those things is responsible for the increase in ADHD. So I'm not going to actually write this down right here. Well, I should write something. You guys should write something for this question. Explain the concept of confounding in the smoking study. Mothers who smoke may also be more likely I'm just going to say this out loud and you guys can copy what I'm saying because it's going to take me too long to write. Mothers who smoke may also be more likely to engage in other unhealthy habits like lack of exercise or poor diets. It could be the lack of exercise and not the smoking that is actually responsible for the increase in ADHD. So something to that effect would be a good full answer for that question. Is there any way to prove it was the smoking that causes ADHD? Well, let's think about that. If I'm not sure if it's smoking or exercise that's causing this, what I would have to do is separate those two things in smoking and not enough exercise and see if one of them makes a difference and one of them is a higher rate. So what that would basically mean is I would say like, oh, I wonder if it's the exercise. I would have to have these moms smoke, these moms also smoke, but maybe these ones exercise and these ones don't, and see if there's a difference between the two groups. In other words, to do this, you're playing with people's lives. It's terrible. You can't do it. In order to know for sure, you're going to have like parents, moms do things that are probably not healthy. So it's extremely unethical to actually test this by breaking people into groups and forcing them to make unhealthy choices. So the design of this study that you guys see right here is called an observational study. So let me go ahead and erase typing here. An observational study is where the researchers measure variables of interest without attempting to influence responses or impose treatments. So let me talk about what that means. The smoking problem we just looked at is an observational study. The researchers didn't tell the mothers whether or not to smoke during pregnancy. They just listened to what the mom said and they passively recorded the data. Okay. So people will sometimes go too far with this. They think observational study, oh, it's passive. Like I could do an observational study right now by looking up data online. I could find something that I'm interested in just by readily available data. I could also be like a researcher calling people in. Like these people got called into the hospital and they were recording information and running tests on them and stuff like that. So you can still be active while doing an observational study. The key wording that you guys need to remember, best way to answer one of these questions, is that an observational study is without imposing treatments. Imposing treatment means you tell the individuals what they should be doing. You will do this during the study. You will not. You will take this new pill to see if it works. You will not. So if you're telling people what to do and imposing that treatment, it's actually an experiment, which we're going to talk about shortly. Observational studies, you do not impose treatments. So in experiments, researchers do impose treatment on individuals in order to measure their responses. Super common AP question. They'll talk about a study. They'll be like, is it observational or is it an experiment? Does it impose treatment? That is what you talk about for your answer. So last thing on this slide is what is the difference between an explanatory and a response variable? First off, I wrote it below. Just realize that explanatory variables in like regular math terms is an X variable and a response is your Y variable. The response variable is measuring an outcome. In our study earlier, it was rate of ADHD. Do you have ADHD or do you not? Explanatory variables are things that seek to explain why you're seeing the response that you are. So it's trying to explain why the rate of ADHD was higher. Exercise, smoking, et cetera, are all examples of explanatory variables in that context. So being able to use that vocab of experiments, explanatory and response variable is pretty important. So we have a new context right here. Go ahead and read this to yourself real fast and try out this slide just by thinking it through before you listen to me. So try to put what we just learned into action on this example and pause me. So now you've paused me, you've tried this and thought about it for yourself. You're not just waiting for me to tell you the answer. Let's talk about this study. Does eating dinner with their families improve students' academic performance? Apparently, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. And it was a nice survey done by Columbia University, very reputable university. Was this an observational study or an experiment? Remember, the key is observational study, no treatment imposed. Did the researchers say you are going to eat with your family? You're not, or try to organize what's going on like that? Not at all. All that happened is they looked and said, hey, how many times do you eat with your family? And then they looked at their grades. So in this problem, this is definitely going to be an observational study. So let me get my pen back here. It is an observational study. Justify your answer. Treatments, and whenever you answer a question in AP Stats, you want to use good context, talking about what the problem was about. Treatments of family dinners is not imposed on the teenagers. So they did not tell the teenagers you're supposed to eat with your parents, you're not, or whatever. They're just recording data based on what is already happening. In this problem, the explanatory variable, what are they trying? Well, it's actually, I think, easier to start with the response variable. What are they trying to measure is the response variable. And in this problem, the response variable appears to be the grades in school. How are they measuring those grades? They didn't say GPA, report card, subjective, I don't know. But the grades are the response that they're looking at. And what are they seeing if it influences their grades? It's going to be the family dinners. So let's see. The family dinners are number of family dinners, although it looks like they've broken into 5 or less, like 5 or more. But yeah, dinners is explanatory and response variable is grades. Why can the study not establish cause and effects? Suggests a variable that may be confounded with whether families eat together. So, just like in my smoking problem, I couldn't make the claim that smoking causes the ADHD because it could have been one of those other things tied to smoking that was actually responsible for the increase in ADHD. In this problem, a little bit lower stakes here than the last one, but we're looking at teens who eat with their family. So if I'm a teen and I eat with my family 5 times a week, what other things could be going on that could be responsible for the grades other than the fact that I was eating dinner? Well, if I'm eating dinner with my parents 5 times a week, that means I'm at home, presumably at a reasonable hour. I probably have more time to study. So it could be that I'm at home, I have time to study. The studying is what's responsible for the grades. It could be, you could sit here and play what if with this for a while. I'm just going to toss a couple common ones out here. It could be that if your parents at home and they have the time to eat with you, they also have the time to help you on your assignments, and it's their help and support that's leading to the higher grades. We can sit here and list thing after thing after thing, all these what ifs. What if it was this? What if it was this? Those variables are confounded. So for this last one right here, suggest a variable that may be confounded. I'm going to go with study time. It's a nice, non-controversial, easy to talk about solution, but you can talk about anything you want to. Kids who eat at home at least 5 times a week with their parents are probably, since they're at home, they probably have more time available to study. And it's that increased study time that is actually responsible for the higher grades that we saw. Okay? You could pick any variable, but talk about how it's related to the 5 times a week. If you're at home for dinner 5 times a week, you probably have more study time. And then the study time is actually what makes grades go up. All right, so we are transitioning now into the concept of an experiment and how you actually design a good experiment that tests what you want it to test. This is actually a lot more difficult than you would initially think, to design an experiment that does what you want it to. It's really not so bad to pick apart somebody else's design, but when you're making your own, what you guys will find out is there's just so many things you have to consider that it's easy to just overlook something completely. So this is a hypothetical study that we're going to do in class. I'm going to do something different with you guys besides with caffeine. We'll talk about that in a lesson or two. But for the purposes right now, what we're talking about is I am going to see if how much caffeine, if you take caffeine through a drink, Pepsi, coffee, whatever, does that increase or have an effect on your pulse or your heart rate? So does taking caffeine make your heart beat faster or slower or whatever? So here's my basic plan. What I'm going to do is have everybody in class measure their current pulse rate. So we'll sit and we'll count it out for 30 seconds and just measure what our current pulse rate is. Then I'm going to pass out some caffeine. So I'll bring soda, I'll bring coffee, I'll bring whatever, just a bunch of stuff, and you guys can just help yourself. Have some caffeine. We'll wait for a specified amount of time, I don't know, 10 minutes, and we'll check again. So we wait 10 minutes, let the caffeine do its thing. We measure our pulse rate at the end, and then we see if there was any sort of a difference between the before and the after in our pulse rates. And then if there is, we can be like, hey, caffeine did this. So want you to think, and again, pause me here, think about potential problems with this plan, because there are definitely plenty of problems with how I currently have this structured. Okay, so pause me, and I'll talk about a couple of the big things that I would want you to consider. So first off, I don't really specify what's going on with the caffeine. How much caffeine should you take? Is it a little tiny little like thimbleful? Is it a big old cupful? Is it up to you how much you have, or is it designated by me? But the amount of caffeine is going to make a big difference in the results of the study. If I'm not having you guys drink enough or too much or whatever, that can definitely have an impact on the results that I end up finding. There's a lot of things that I need to fine tune if this was going to be my actual presentation here. The second part of this question, though, I'll address it in there. It says, what other variables are most likely to be sources of variability in pulse rates? So what else besides the caffeine may cause extra variability in our results? So a couple things that I would hope that you guys could appreciate, or maybe you've thought of some of these yourself already. One thing that is really a big deal is caffeine tolerance. So if you're somebody who chugs a couple monsters before school every day, you've got a lot of caffeine in your system already, and your body just isn't going to be affected much by whatever little cup of soda or coffee I give you. So if you're already very tolerant to caffeine, we're not going to see much of a change in your pulse rates. On the other side of things, if you've never had caffeine before in your life and I give you a big cup of coffee, your heart is probably going to race quite a bit because your body isn't used to it. Other things to consider, athletic ability can have, or athletic conditioning, I should say, can have an impact on heart rates. Your resting heart rate is actually slower when you're more conditioned and more athletically in shape because your heart is stronger and can pump more blood with each beat. So if you are somebody who works out a bunch, your heart rate is probably lower to start with. Now, does the caffeine make that way higher, or does it not change it as much? We don't know. I don't know going into the study, but that would certainly be something to consider as well. There's also other factors. How stressed are you this day? How tired are you? All these different things that can influence pulse rates. And if I'm not careful, my study will just get overrun by all of these things. So we have what are called principles of experimental design, which are different things to consider to make sure our experiment does what we actually want it to do. And the first principle, which we're covering in this video, has to do with how we structure the testing in the first place. So what we need to do is include in our study a control group, is what I'm going to write in the blank right here. Control group is a little bit of a buzzword, like kids know this. You've probably heard this in some science-y class before. Oh, gotta have a control group, and that's like just something people usually know. We'll talk a little more about that and break it down, though. So it's not just simply a buzzword here. All of this is providing a comparison. I'm going to run out of room right here. So this provides a comparison for us in our study. Okay, so let's talk about the first initial flaw in my little caffeine study. If I just give everybody caffeine and we check 10 minutes later, I can't really be sure if there is an increase in pulse rates, if it's because of the caffeine or some other confounding factor like we talked about earlier in this section. Maybe to toss out like a, I don't know, quick example here, maybe the heat gets hotter in my room, in the classroom while we're doing this, and the heat increase is responsible for the heart rate. Maybe Dr. Guerrero comes on the announcements, makes an announcement about some big test or something happens. I say something that reminds you, oh, the ACT is this weekend, and your heart rate rises because of this. Or maybe I decide I'm going to use my time well in these 10 minutes and teach you guys some amazing statistics, and your heart rate just rises because you're just so thrilled with the amazing statistics that I'm teaching you. All of those could be responsible for the pulse rate. And if everybody got the same amount of caffeine, I couldn't say for sure if it was the soda or me or the temperature in the room or any other number of factors that's responsible for this. So the best thing to do in this situation would be to randomly break you guys up into groups. So some of you got the caffeine and some of you did not. Why is that helpful? Well, if some of you got it and some of you didn't, if I have a difference between the groups, let's say I actually do the study and there is a difference, all of you heard the same stats lecture in those 10 minutes from when you took the caffeine, all of you have been experiencing the same temperature, et cetera, et cetera. You guys should, in theory, in the two groups, have gone through all of the same stuff in that 10-minute interim. So the only difference between you is the content of your beverage. So that would be a situation where I could say pretty confidently that it was the caffeine that caused that difference. So let me check. I forget where I end these slides. Oh, I got vocab there. Okay. We'll talk a lot more about flaws in this design in our next video, but I want to close this out by talking about a little bit of vocab related to experiments. So you guys can go ahead and copy these down right here, and I just want to talk very, very briefly about them. A lot of this is just terms you need to know. Treatment is what you're actually doing, so it'd be caffeine or no caffeine. What the experimenter, like the group that they put you in, or what they're imposing upon you. That one's pretty straightforward. Experimental units are the basic unit or the basic individual or whatever that you're imposing treatment on. This is actually a little bit more nuanced than you would think. So I want to give an example from a recent AP test, like a couple of years ago. There was a problem where they had these jars of insects, and they were putting different amounts of a chemical in the jar to see what it did to the insects. And they were like, I don't know, 20 jars or something like that, and they had 4 different treatments for them. So the question on the AP test asked, what were the experimental units? And people said, oh, it's the insects. The insects in the containers, they're the ones who are experiencing the chemicals. But the treatment was imposed on the different jars. The jars were the experimental units in that problem because they were the smallest thing that got the different treatments. All the bugs within are part of that larger whole of the jar. So experimental units are what you impose treatment on. It's the jars, not the insects, in my little example right there. You guys would be my experimental units in the caffeine problem. But when it's a human who you are testing on, you don't call them an experimental unit because that's very off-putting and weirdly impersonal. We tend to call them subjects instead. So subjects is a word for human, experimental units. A factor is another word for your X variable or explanatory variable. So a factor and an explanatory variable are synonyms of one another. And lastly, level refers to the value of your explanatory variable. So in my problem, the levels would be no caffeine and caffeine. But maybe I wanted to see if I could do no caffeine, little bit of caffeine, medium caffeine, high caffeine, or specify like the milligrams that you'd be getting. Each of those, like so 0, 15 milligrams, 30 milligrams, whatever, would be a level to my explanatory variable. And we will talk more about this in our next lesson.